first we looked at modeling of tracers they co-injected with the CO2. So they can do a little pulse of a tracer they can detect at very low concentrations. You can see how long it takes for the tracer to go from the injection well to these observation wells. And in a groundwater paper we looked at what happens to the methane that might already exist in this aquifer. So a lot of aquifers have this methane dissolved in the brine. When you inject CO2, actually the CO2 dissolves, the methane exsolves. Now you're forming a free phase of gaseous methane that's moving through this aquifer. And there's some concern that this free gas might leak towards fractures or abandoned wells in the cap rock. Of course, methane is a more potent greenhouse effect than CO2, so you don't want to inject CO2 and then have methane leaking out through abandoned wells. So we did detailed modeling of both those problems. So this is kind of our computational grid. It's very complicated geological heterogeneity of multiple phases. So there's high permeability channels with low permeability phases in between. So then we get simulation results like this, where you can see CO2 from the injection well. This is like kind of a top view of the simulation. It's going through these high permeability channels here. These are side views, so you can see it's also very layered if you look at a cross section. So in this case, you see a lot of CO2 kind of goes through the middle of the formation, doesn't really go much to the top.